In this problem, I want to verify the following identity. The tangent of theta plus the cotangent of theta equals the cosecant of theta times the secant of theta. So, I think we need to work on the left-hand side because it looks more complicated. So if I'm going to rewrite the left-hand side is the tangent of theta plus the cotangent of theta. Now notice, this one, in this example, all the arguments of the trig functions are the same. It's just theta, so I don't have to mess with any double angle formulas or half angle formulas. But I have four different trig functions: tangent, cotangent, cosecant, and secant. So I think it might be better if we write everything in terms of sines and cosines. So remember, the tangent of theta is sine theta over cosine theta. These are identities that you should know by heart. The cotangent of theta is the cosine of theta over the sine of theta. And let's just look at the right-hand side while we're writing out some of our basic identities. The cosecant of theta is 1 over, remember, the sine of theta. And the secant of theta is 1 over the cosine of theta. So I'm going to work on the left-hand side. So I'm going to write the tangent of theta as sine theta over cosine theta, plus the cotangent of theta is cosine theta over sine theta. So now you notice I have two fractions, and I think I'm going to have to add them up because on the right-hand side I just have one expression, not two. So I need to find the least common denominator of both my terms on the left-hand side. So the LCD is you need your first denominator, so I need a cosine theta. And now go to your second denominator, I also need a sine theta. So my LCD, least common denominator, is cosine theta times sine theta. Now remember, I'm just working on one side at a time. I can't multiply by the LCD to get rid of my common denominators. Instead, I have to write everything over the least common denominator. So this first denominator has cosine theta in it. What am I missing? I'm missing a sine theta. So I have to multiply the denominator by sine theta and the numerator by sine theta, because really, what am I multiplying by here? Just 1, because sine theta over sine theta is equal to 1. Now I'm going to write out my second term, which is cosine theta over sine theta. And now what's missing in this denominator? I need a cosine theta sine theta. I only have sine theta, so I need to add a cosine theta. So I'm going to have to multiply numerator and denominator by cosine theta. So now this denominator, cosine theta times sine theta, is equal to sine theta times cosine theta, because remember, multiplication is commutative. So I'm going to write it as sine theta cosine theta. I could have written it the other way around, cosine theta times sine theta. Now let's look at the first term in the numerator. I have sine theta times sine theta, which is sine squared theta. Remember, we write it that way for convenience sake, plus cosine theta times cosine theta is cosine squared theta. Well, now you should be looking at this numerator going sine squared theta plus cosine squared theta equals 1, because that is the most important Pythagorean identity. So now I just have 1 by the Pythagorean identity in the numerator over sine theta times cosine theta, which we can break down as 1 over sine theta times 1 over cosine theta, because 1 times 1 is 1, sine theta times cosine theta gives me this denominator. And then what is 1 over sine theta? Cosecant theta. What is 1 over cosine theta? Secant theta. And is that what we were trying to prove the right-hand side equaled? Yes. So I have proved that the left-hand side equals the right-hand side, so I have verified that identity.